All right, you guys, let's continue our discussion about linear equations. So remember, any linear equation in two variables can be written as ax plus by equals c. We call this form standard form, okay? And it says where at least one of a and b is not zero, okay? So anytime your equation is written in that form, ax plus by equals c, we call that standard form. So the shape that a linear equation makes, if you were to graph it, is called a line. And a line in itself represents an infinite number of points, which means that there are tons and tons and tons of points, more than you could possibly count on a line. However, if you need to graph a line, you only need 2 points, okay? So if you were ever asked to graph a line, the first thing you're going to do is you're going to find 2 points that lie on the graph of the line. Then 2, you're going to plot these 2 points on the rectangular coordinate system. And then 3, you're going to draw a line through the 2 points to form your final line. Okay? So we're going to walk ourselves through these steps. We're going to do a couple of example problems, so don't worry. Okay, so the system that we're going to be drawing our lines in, which I'm pretty sure you guys have seen before, is called the rectangular or the Cartesian coordinate system. Okay, so if you ever wondered where the name Cartesian comes from, okay, it comes from a mathematician in the 17th century whose name was Rene Descartes. So the name of the system comes from the last part of his name. So little interesting fact. So if you're ever looking at your coordinate system, okay, you have 2 main lines that split your coordinate system. You have the x-axis, which is this horizontal line that moves from left to right in your system, okay? And you also have this vertical line, which is the y-axis that moves up and down, okay? When those 2 axes cross, okay, they cross at a point which we call the origin, whose coordinates are 0, 0, okay? Now, when those 2 axes cross, they split this plane into 4 different parts, and those 4 different parts are called quadrants, okay? The prefix quad means 4. So those quadrants are numbered starting from the top right-hand corner and moving counterclockwise. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? Now, depending on where your coordinates are, it tells you where you're going to move either left or right. So every time we are given a coordinate, we are always given an x, y coordinate. Your x value always comes first, and your y value always comes second. Your x value tells you how far to move either right or left, and your y coordinate tells you how far to move either up or down, okay? If your x coordinate is positive, you're moving to the right. If your x coordinate is negative, you're moving to the left. If your y coordinate is positive, you're moving up. And if your y coordinate is negative, you're moving down, okay? Now, based on where you finally land, the quadrants will tell you that. So if you're in quadrant 1, it means that both your x and your y coordinate were both greater than 0, which means that they were both positive. If you land in the second quadrant, it meant that your x coordinate is negative, but your y coordinate was positive. If you're in the third quadrant, it means that both your x and your y coordinates were negative. And if you're in the fourth quadrant, it means that your x value was positive, but your y value was negative, okay? So remember, we use a coordinate or an ordered pair to move within this plane, and depending on if your x or y is negative or positive, dictates the direction in which you move. Cool. All right, so let's see if you guys remember. So how many points or a point lie along the graph of a line? Well, an infinite number of points, okay? But remember, you only need 2 points to graph a line. All right, so let's look at our first picture of a line, okay? So the equation that they gave us is y plus 2x equals 4, okay? Now the beautiful thing about a line is that you only need 2 points to graph it. Whatever those 2 points are is entirely up to you. So some people like to graph lines by a method that they call plotting points, okay? And plotting points means is that you choose whatever x value you want and you plug it into your equation to find the y value, okay? So for example here, okay, they chose that x is going to equal 1. And the reason why we can choose whatever value we want for x is because x is our independent variable. It depends on what we choose it to be. So they let x be 1. So in this equation, if you let x be 1, you have y plus 2 times 1 equals 4, which would be y plus 2 equals 4. If you subtract 2 from both sides, y equals 2. So that's how they got to the second value. And then what that tells you is that when you plug in 1 into that equation, 2 comes out. So that corresponds to the point 1, 2, okay, which is the point that they've graphed here, okay. Now you can do that for as many points as you want to. Choose whatever x value you feel like, plug it into the equation and find its corresponding y value, and then graph that ordered pair, okay. Now, you'll notice when we get to start graphing our lines, you are going to run into some special points that have special names. So 2 of those points are our y-intercept, okay, and our x-intercept, okay. Now, if we look at the graph, those points have special names because special things happen if you look at the graph. So your y-intercept, if you look at our line here, you will see that this is the point at which our line crosses the y-axis, okay? And if you look at our x-intercept, it is the point at which our graph crosses the x-axis, okay? So your line has these 2 special points, okay? Now they may not always have both of them, okay? But more than likely they're going to have one. So your graph could have a y-intercept and an x-intercept, or it may just have a y-intercept, or it may just have an x-intercept, depending on how it's drawn, okay? So let's look at more specific definitions for our intercepts, okay? So depending on what they ask you to do, if they give you a graph and they ask you to identify the x-intercept, that's easy. All you need to do is look to see where your line physically crosses the x-axis, okay? So in this picture you can see here, this is our x-intercept. Now, if you've been given a picture, you can look at and identify it. But if you've been given an equation, the way that you find it is that you're going to set y equal to 0 and you're going to solve for x. So that means in your equation, like in this example, everywhere that you see a y, you plug in 0 for y and then you solve for x. So in this case, you have x equals 2. That is your x-intercept. Now, any x-intercept that you have, you're always going to write it in the form x, comma, 0. The y-coordinate will always be 0, okay? Now, you're going to do the opposite if you're asked to find a y-intercept. So once again, if you've been given a picture, your y-intercept occurs when your graph crosses over the y-axis, okay? But if you haven't been given a picture, if you've been given an equation, you're going to set x equal to 0 and you're going to solve for y. So in the same equation now that I'm looking for the y-intercept, everywhere that I see an x, I plug 0 in for x and then solve for y. So I end up with y equals 4. And if I write that in its coordinate form, y-intercepts always take the form 0, comma y. So I would write this as 0, comma 4. Okay. Now, the way that I remember it, whatever intercept I'm trying to find, I set the opposite variable equal to 0. So if I'm looking for x-intercepts, I set y equal to 0. If I'm looking for y-intercepts, I set x equals 0. So it's always the opposite. Okay. So let's take what we just learned to see if we can graph a line on our own. So in this example, it says graph the linear equation 3x plus 6y equals 12 using the intercept method, okay? Now what the intercept method is, all that's telling you to do, okay, is to find the x and y intercepts. Okay, so if they want us to find the intercepts, okay, I'm going to use what I just learned previously. Now, when you find them, the order in which you find them doesn't matter. If you want to find the x-intercept first, go for it. If you want to find the y-intercept first, go for that. Usually, typically, I find the x-intercept first, just out of habit, but you don't have to if you don't want to. So if I'm looking for the x-intercept, remember that means that I need to set y equal to 0. So everywhere in my equation where I see a y, I'm going to plug 0 in its place. So that's 3x plus 6 times 0 equals 12. And I'm going to solve this equation. So 6 times 0 is 0, and that's going to give me 3x equals 12. And then I'm going to solve for x. So I'm going to divide both sides by 3. So x equals 4. So remember, in its coordinate form, that's going to be 4, 0. Okay. All right, let's find our y-intercept. So remember, whatever intercept you're trying to find, you set the opposite variable equal to 0. So this time, I'm going to set x equals 0. So everywhere in that equation where I see an x, I'm going to plug in 0 in its place. And I'm going to solve this equation this time. So 3 times 0 is 0. And then 6y equals 12. To get y by itself, I'm going to divide both sides by 6. So it's going to give me y equals 2. So in its coordinate form, I'm going to write 0, 2. So remember, you only need 2 points to draw a line. And by finding the intercepts, I now have 2 points. So if I want to draw my coordinate system, I'll make a sketch. Okay, I'm going to plot my x-intercept first. So my coordinate was 4, 0. So my x value is positive, which tells me I'm going to move to the right 4 places at 0. And then I'm going to plot my y-intercept. So my y is 0, my y is positive, so I'm going to move up 2. And I'm going to connect my points. And there's my line. Okay, so anytime they want you to find the line or draw the picture and they want you to use the intercept method, all they want you to do is find the x and y intercepts and then connect those points. Okay, so let's try another one. Cool, so this is the answer to the one we did above. So we did it correctly, go us. All right, let's try this one. Okay, so once again, they want us to graph it using the intercept method. So remember, that means we're going to find our x and y intercepts if we have them and then plot them. So I'm going to find my x-intercept. Remember, that means set y equal to 0. So everywhere in this equation where I see a y, I'm going to make it 0. And I'm going to solve this. So I have negative 3x. Negative 5 times 0 is 0, equals 15. And then for this problem, I'm going to divide both sides by negative 3. So x equals negative 5. Cool. So as a coordinate, that's going to be negative 5, 0. All right, now let's find our y-intercept. So remember, for y-intercept, that means we're going to set x equal for 0. So everywhere in this equation where I see an x, I'm going to plug in 0 in its place. So I have negative 3 times 0, which is 0. It's negative 5y equals 15. And I'm going to divide both sides by negative 5. Y equals negative 3. So as a coordinate, that's going to be 0, negative 3. So now that I have my x and y intercept, I can graph them just like I did for the problem above. So I'm going to go ahead and sketch in my coordinate system. All right, so to plot my x-intercept, my x is negative this time. So that tells me to move to the left 5 places. 1, 2, 3, 4, 5. And my y-intercept is also negative. So that's going to tell me to go down. 1, 2, 3. And then I connect my points. So hopefully yours is a little straighter than mine. I'm on a tablet, so I'm doing my best. And there's our line. All right, let's try another one. So let's see if we're correct. Yep, we're all set. All right, let's look at this one. So they want us to graph the linear equation. Now, one thing you'll notice is that this equation looks a little funny. All of the equations we've had before have had both an x and a y, but this one only has an x, okay? So this is a special type of equation, okay? It generates a special type of line. So anytime you have x equals some number, okay, that is always going to be a vertical line. Okay, because it has no y in it, automatically this line is going to go up and down through the point that they gave you, which is 2. So if you were to graph this line, okay, it's going to be a vertical line that goes through x equals 2. So it looks like this, okay? Now you'll notice, because it's a vertical line, which intercept does it not have? It has no y-intercept, okay? So vertical lines, or at least this one, has no y-intercept. It doesn't cross over the y-axis, so it has no y-intercept. Now it does have an x-intercept, the point at which it crossed through. So its x-intercept would be 2, 0. Okay, so it's important. Anytime you see x equals some number, that is going to be a vertical line. Okay, now let's look at another problem. Okay, so if you want to try this one, graph x equals -3. See if you can do that one and see where it's going to turn out to be. Okay, now let's look at this case. Now this isn't also a special case of a line. This is y equals -2. So you'll notice in this equation, okay, we don't have an x in this one. So anytime you have y equals some number, I'll call it b this time, this is going to be a horizontal line. Okay, so if I were to graph this one, so let me sketch my coordinate system. Okay, this line is going to go through y equals -2. So -2 tells me to go down, and this is going to be a horizontal line. Okay. Now you'll notice this line is also missing an intercept. This one is missing an x-intercept. Okay, it never physically crosses the x-axis, so there's no x-intercept. Okay, but it does have a y-intercept. Its y-intercept is the point at which it crossed over the y-axis, which is 0, -2. Okay, so anytime you're drawing lines, be careful for those two cases, because your line could end up being vertical or it could end up being horizontal. Cool.